Have you ever been to the beach and accidentally swallowed a mouthful of ocean water? It's incredibly salty. But have you ever stopped to wonder why? Why is the massive ocean full of salt, but the river flowing into it is fresh? Imagine standing on a coastline, watching the waves crash. You can feel the spray on your face, and you can taste the salt in the air. The ocean feels like a completely different world compared to the water we drink. Now think about a stream you might see in a forest, or even the water that comes out of your tap at home. It's fresh, clean, and has no salty taste at all. These two kinds of water are connected. Rivers from all over the world are constantly flowing into the ocean. So if fresh river water is always pouring in, why doesn't it dilute the ocean and make it less salty? The answer is a journey that takes millions of years. Our story doesn't start in the ocean. It starts in the sky with a simple raindrop. As rain falls through the atmosphere, it collects tiny particles from the air. One of the most important things it picks up is carbon dioxide. When water and carbon dioxide mix, they form a very, very weak acid called carbonic acid. It's so weak you would never notice it, but it's a powerful force of nature. This slightly acidic rainwater falls everywhere, on forests, on cities, and most importantly, on rocks and mountains. Think of a huge mountain range with rocks that have been sitting there for millions of years. Every time it rains, this weak acid ever so slightly eats away at the surface of these rocks. It's a process called erosion. You can't see it happening with your own eyes, but drop by drop, year after year, the water is breaking the rocks down. As the rocks break down, they release tiny particles of what they are made of. These are called minerals, and many of these minerals are different kinds of salts. The most common one is sodium chloride, which is table salt. Now, where do all these tiny, invisible salt particles go? They get washed away by the rainwater. The rainwater collects into small streams, which then flow into larger rivers. So, all the rivers in the world are actually carrying a secret cargo. A tiny, tiny amount of dissolved salt washed away from the land. This brings us back to our earlier question. If rivers are carrying salt, why don't they taste salty? It's a matter of concentration. The amount of salt in a river is so small, and the volume of fresh water is so large that your tongue could never detect it. But even though the amount is small, it's always moving. Every river is like a slow-moving conveyor belt, transporting minerals from the land to one final destination. That destination is the ocean. For millions and even billions of years, rivers from every continent have been emptying their water and their tiny load of dissolved salts into the sea. The ocean acts as a giant collecting basin for all the minerals of the world. You can think of it like a giant soup bowl, and the rivers are constantly adding a little pinch of salt. But this is only half of the story. If rivers are always adding water, the ocean should be overflowing and getting less salty. Something else must be happening, and that something is powered by the sun. The sun shines down on the vast surface of the ocean, warming it up. This warmth causes water to do something amazing. It evaporates. It turns from a liquid into a gas, called water vapor, and rises into the atmosphere. This is the beginning of the water cycle. That water vapor will eventually form clouds and fall back down as rain, starting the whole process over again. But here's the crucial part. When the water evaporates from the ocean's surface, it leaves everything else behind. All the dissolved salt that was carried in by the rivers does not evaporate. It stays in the ocean. So for millions of years, you have two processes working together. First, rivers are constantly delivering a small amount of salt into the ocean. Second, the sun is constantly removing fresh water from the ocean through evaporation, leaving the salt behind. Imagine adding a spoonful of salt to a glass of water every day, but every day, some of the pure water evaporates away. Over time, that water would get very, very salty. That's exactly what has happened to our oceans, but on a geological timescale that is almost impossible to imagine. There's one more source. Deep on the ocean floor, there are hydrothermal vents. These are like underwater volcanoes spewing out super hot water filled with minerals from inside the Earth itself, adding even more salts to the mix. So the ocean's saltiness is the result of a planet-wide system working in perfect, slow-motion balance for eons. This reveals a powerful idea about how our planet works. Small, almost unnoticeable changes can have enormous effects when given enough time. A single raindrop can't do much to a mountain, but billions of raindrops over millions of years can wear that mountain down to nothing. A single river carries almost no salt, but all the rivers, flowing for ages, have filled the entire ocean with it. This principle of slow accumulation is a key to understanding Earth science. It's how canyons are carved, how mountains are built, and how the oceans became what they are today. So the next time you stand by the ocean, think about the incredible journey of a single grain of salt within it. It might have started as part of a rock on a mountain hundreds of miles away, broken free by rain, and carried by a river on a long journey to the sea. Salt in the ocean is a liquid library, holding the dissolved history of all the lands on Earth.